All right, so first of all, I think I'm super happy that Joao was before me because he took one of the buzzwords and explained it before I need to, and that is what are products. But I have another buzzword here in my title, which is lean principles. And to be honest, I know that the audience is quite technical, right? So when I talk to technical people and then I mention things like lean principles, product development, product thinking, design thinking, everybody rolls their eyes and says, Boyan, why do you talk like a management consultant? And I mean, I am a management consultant, so I need to talk like this. But my job today is to explain why those words are actually important for us and how can we use this to reduce the complexity of our work. But first of all, I'll start with a story of pain, which I think all of us here, I was a data scientist before, and I think everybody can find themselves in this story. And I'll do a spoiler alert about the current state of data. And the spoiler is that it's really not great. And I try to draw all of the pain that we have as data scientists, data engineers, in one diagram. And I personally like to call this the implementation maze. You can find other nice words for this. But basically, all of the pain in our field you can summarize here. So let's imagine you work in a normal company and the business tells you, Boyan, please do some like AI for logistics. And then I say, okay, take a team and start working. And here on the left, you have a very typical team, product owner, data scientist, data engineer, data analyst. And then from left to right, we're working on a project. The red arrows, they tell you the situations where there's stress being given to a person, basically when somebody is really mean to somebody else. The red circles, they're like, you can imagine these are the bombs. These are situations where your whole project can die, right? And you see there are quite a few of those. And what happens at the beginning is, and now as a data scientist, at any project I started, the first thing you ask, where's my data? And who do you ask? Unfortunately, you talk to your data engineering friend and ask them, hey, hello, my friend, can you give me some data so I can get working? The data engineer at that point says, sure, I'll do this for you. So they drop their work and they try to look for data for you. At the same time, what happens a bit later is the data analyst asks the same. So can you give me some data? But they ask for data access. For example, they work in Tableau, they want to build some dashboard, but they also need data for that work. Now, the data engineer at this point starts to get a bit pissed off, a bit unfriendly maybe to everybody, but they still do it. Unfortunately, me as a data scientist, one mistake that I did early on was trying to build a prototype and just giving it to the data engineer without thinking too much. What I did back then was I made like my model in R, which is a great language, by the way, but still my data engineer colleague wasn't very happy that I give them the model in that form. And they had to recode all of this. Yeah, we call this the throwing over the fence type of problem that we have. At this point, many projects can die. That's why you have the circle there. At this point, also, the product manager starts to ask questions. Guys, what's going on, right? I gave you the problem. You have whatever, the people, you have the data, but nothing happens. What's going on? You're still looking around like a headless chicken. And so they start to give stress. Somehow the data engineer survives all of this, and we get to the deployment part. And again, we have a lot of talks today about MLOps. I mean, it's kind of like people start to work on this too late in the process. And everything starts to get delayed at this point. And my final like nail in the coffin of data science is the now what problem, which the product owner faces. Imagine we spend like 2 months building the perfect model, and then we go to our client, let's say, and then they say, okay, we don't need an API endpoint, we need like some graphical interface. And then we go back and say, well, we need to build this now, right? So this is the very typical thing. And I call this like digging the perfect hole in the wrong garden type of problem. So this is the pain, and today I'll talk to you about how we can avoid doing this. But first I want to go back to a philosophical thing. Actually, this painting is drawn by Dali, and I was very happy that it made the fingers correct. Maybe you can count them, but I think all 5 are there. But it reminds me, so the via negativa philosophy is from Latin, it means a negative way. And I can provide you the example of how this works. When I was a child, for example, my parents gave me this advice. I think many of you can relate. Boyan, to be successful in life, you have to get a good job, work very hard, have good friends. And I was thinking, yeah, that's a bit obvious, right? And the sky is blue and you have to be nice. I mean, what can I do with this? And the idea here is that the negative advice, if you try to flip this advice around, is very productive. If my father would tell me, like, don't smoke, don't lay around, like, don't do drugs, whatever, that is very easy to act upon. So this act of reducing things, it's much more productive. And I'll give you some examples. Have a look at the books. They're very good for all of us. And finally, like, we talk about frameworks, we talk about ways of working, and one important thing to keep in mind is what works for my company, what works for my startup, whatever, is not going to work for yours. The most typical thing that we do is we have a look at Google and we think, well, they have this new fancy way of working. Let's just copy and paste this, right? I think I was talking to Nemanja actually earlier today about copying frameworks, right? Like, for example, if Google, like the famous Spotify model that everybody knows about, if you read now that Spotify themselves says this doesn't work. Like, and in Germany, I have the feeling, because I come from Germany, we're still doing this. You still go around and see companies doing the Spotify model, while everybody already knows it doesn't work, Spotify themselves. This is the so-called cargo code, basically the idea that you just copy some kind of methodology and nothing without the context, and you pray for good results. So just pay attention to this when you just take frameworks. Now, if I think some of you might be having a data mesh in your company, but probably there's quite very few of those. And when you say data products, in the data mesh context, we really talk about just data. But if you listen to Joao, he also went into this direction. We can expand this definition to include other things, not just data. And when we talk about data products, we can go through the data science hierarchy of needs, and you see this in the pyramid to the right. So on the bottom, we have the data engineering part. On the middle, we have the data science. And on top, we have the fancy stuff, the ChatGPT or whatever, the AI. So to do the advanced analytics, you need the foundation. That's the basic idea. And on all of those levels, you have different types of products. If you have a look at the lower level, you have things like InfluxDB, which is a time series database. That's a real product which the company monetizes. Kubernetes, I urge you to have a look. There's very nice documentaries how that came up at Google. This is also a product. A Grafana dashboard that you're building with your BI people, again, you can see it as a product. And finally, any image classifier, perhaps, that your data scientists are doing, this should also be seen as a product. Why is this important? Yeah, have a look at the workflow below, right? You need to, any type of data science or engineering work you do needs to focus on small things. Like, you look at it as a proof of concept first, MVP, and then iterate on the product versions. What people forget here is that products also die. Yeah, you deploy your model, you develop it, it gets the feedback. You maybe have several versions of this, but at some point a better model comes in. So you need to be able to retire this. And finally, product thinking allows you for this ownership. Now I come to the management consulting part. When I talk about thinking, there's a big contrast between projects and products. And I know sometimes it is frustrating to think about those things because it just seems like semantics. But when you tell people we are doing a project, as a manager, sometimes I also think I have my most expensive smart people. They're just working on something, yeah? But what's the outcome of their work? But if you tell them you're building a product, it's much easier to focus on small things which are focused on the user. Who do we build this for, right? The most common thing with technical people do is we build something very advanced, very fancy, but then there's nobody to use this. Another thing is very important here is that you focus on iterative development. You try to build things which can be improved upon. And finally, for product, I think we heard this in the keynote today as well, the importance of metrics, yeah? We talk about large language models. Sure, you deploy such a product, but how do you prove, and we know the API from OpenAI is quite expensive, how do we prove how much money this made for us? And there's, of course, things like A/B testing or many other things you can do in the product world that we can take in data. Now, Amazon, they have the working backwards method, and this is an interesting idea for all of us technical guys. Instead of building a technology, then looking for a market, and I did this also as a CTO, and that's why my startup didn't succeed. We build a fancy technology, try to sell it then. You do the opposite. You kind of don't write a single line of code. you try to write the press release first. And the press release is basically an official document. Let's say Amazon builds a new product like Amazon Bedrock, perhaps, and they publish, this is how it works, this is the business problem it solves, and it's a real big document. And you take this document, imagining a real product, and you go around the company. And you say, well, this is the product, would you use it? And then you gather the signals that you need to build this thing then. And only then you go back and you start to build the roadmap, you start to deploy the product. I think this is a very extreme way of doing things, but I have seen this work very successful in companies. Now, coming to the buzzword in my title, lean, and unfortunately, like in our data field, we talk a lot about agile, and I think not enough we talk about the lean principles. So lean is basically the philosophical thing which I mentioned, the via negativa, applied to software. The origins are in Japan after the Second World War, where we had the economic miracle there, where the Japanese people didn't have a lot of resources, but they had to get their economy back running very fast. And they decided to do something very different. Instead of focusing on how to build the best factory, they focused on the biggest factory, they focused on building the most efficient one. So things that you see right now, like just-in-time delivery, the Kanban, all of those things come from the lean manufacturing in Japan, specifically Toyota. It is similar to agile in some ways, right? Because you also have continuous learning and all of this, and it's cross-functional. I'll show you that in a second. But the whole point here is you try to eliminate waste instead of adding things. Now, this is like a fancy management consulting tool that we use, value stream mapping. And when people ask me what is an important thing for a data scientist or engineer to do, and I tell them understand the business, I always add this method to that, because they ask me, what do you mean understand the business? And I always tell them, make a value stream, map the value stream. So basically any business that we have, you can map it in this way, right? Let's imagine you have a company which sells socks and you work as a data scientist there. What happens in the information flow, this is the flow of data. Some customer purchases a product, then it goes to the factory, the sock is being created, right, manufactured, and then it gets shipped. Right, so if you make this for any organization, you understand the business end to end, you start to see how data can help those different areas. But most importantly, the swim lane on the bottom, the lead time, that's the most important thing for you to understand. Those things, any of those steps takes time. So let's visualize the implementation maze that I showed you at the beginning, this story, the nightmare story. Let's just take one element of this, and this is the waste of time. Our data people waiting, or the data engineer waiting for something. We can just visualize it like this. Imagine we have this sea, and we have the red line, and everything under the red line is the deep ocean of unproductivity. Nobody's doing anything there. And anything which happens above is the islands of work. And I'll be honest, if you do it for your data teams, or if you as a data person does it, you get to a similar ratio like here. I think here I have 60% if you count the days, 60% efficiency. So our data scientist needs to wait because they need access to data. Then they need to get resources from IT for their fancy model, right? So those things take time, and I think even the most productive teams have a lot of waste of time. So just do this and go to your management and say, well, this is our productivity, and this is a typical source of waste you can optimize. This is not the only source of waste. Yeah? And this is what I meant when I said, when you as a manager specifically look at your data people, and there's so many different things that go wrong in that scenario, right? You have like partially done work. This is, as I mentioned, the data scientist building their model and then just throwing it over the fence to the data engineer. Vague definitions of done, this is my favorite. This is now what problem, right? So nobody defines things. And I have a good friend of mine who works for a big food delivery company in Berlin. I'm not going to mention it. But so he works in MLOps in that team, and they built a very, very powerful model, which was, in his view, very impressive, right? With the architecture, the data, accuracy, all of this great. Then they deployed this. Then I went to the product team and said, we're done. And our latency is 1 second. Which the data team thought is great. But the product team said, are you serious? Are we going now to make our users wait for 1 second with a spinning wheel? So they were really pissed off. What happened there is like the data engineering team need to go back and restructure the whole architecture. To go from a latency from 1 second to 100 milliseconds, you need a lot of expertise. So, but if this was defined before the start of the project, they wouldn't have this problem. Multitasking, this is our data engineer doing 20 things at the same time. Unreproducible work, you know all about this. Non-utilizing talents, you have our data scientists. My first data science job was writing SQL. Lack of knowledge sharing, all of those sources of waste you can identify for your organization and fix them. Now, I'll give you one final method that you can use for reducing the complexity, and this is something I call closing the loop. And if somebody here is from Spain, maybe you can recognize the building to the right. This is the famous Gaudi Cathedral, as Dali imagines this. And our business people, they want us to build cathedrals. They want us to build amazing products which are going to be a hit in the world. But Gaudi, and I think that cathedral is still not done. I think they spent 700 years doing this, and it's still not finished. The problem is, how can we take those expectations that we have from management and try to still get something done? The way to do it is by closing the development loop very early. I can give you several examples here, but let's imagine, because the technical audience here, let's imagine you're a data scientist. You get a very big data set, and your job is to build a churn model. Well, you might have like maybe 200 columns in your data set, and you understand just, 20% of them. The rest of them, you need to ask IT, you need to ask some business person to tell you what those columns are. So instead of building a data dictionary, understanding all the features first and then building a model, what you should do perhaps is take the maybe 5 features you understand, which kind of like more probably numerical features like dates, durations. In churn modeling, duration of time is one of the most important ones. Take those features and start working with them, yeah? The other benefit of taking such features, and then we go to the middle of such a project like the data transformation, maybe instead of choosing like, some kind of deep learning model, which is hard to build, take the stupid random forest from scikit-learn, right? I mean, you don't need to rescale your data for this to work. It works very well with missing data. So and you build the most stupid model you can do at the beginning, right? It might have, 55% accuracy on balanced classes. You don't show this to your product people because they'll be disappointed, but build this model first. Then you talk to your ML ops people, tell them, here's my model, it's not great, but please deploy this. And this is something I very rarely seen, because people wait till the end of the project to get this work done. But if you do this early enough, the whole architecture is ready. Yeah, you have your stupid model deployed and it's connected to some kind of other system, maybe to the Excel of some salespeople, right? They're not happy with the performance, but you're happy with the first version of the product. And then it can be measured. Then the customers see this, they can give you feedback. Does this prediction work? What happens? There is a latency bad. And only then, once you have proven this value, then you can go back and build something on the next version. Now, I have just 3 very important things to summarize from my talk. The first essential thing is you need to think in products. And this is not like the consultant in speaking is really the data science as well, right? I was always frustrated with good work being deployed and nobody uses this. So you can avoid a lot of this if you look at your work as a product which can be measured. Build backwards. Instead of inventing a technology for a market which doesn't exist, try to explain your idea to people and then only build it. And finally, instead of focusing on like more superficial things, look at your data team, look at the sources of waste that you can eliminate. And I think then you can be successful. But that's it for me, so thank you for this.
Thank you so much, Boyan. So now it's time for questions. I'll start with one while you still are warming up. I really like the idea of reducing complexity, and I'm not a product manager, but when a product manager comes with that idea, sometimes I feel that if you reduce too much complexity, the product that you're going to design is going to be conditioned.
Yeah.
For instance, on the churn example, I can do a classification model, and I'm reducing complexity to the most, but I could do a reinforcement learning system, and I could experiment with segments that João was talking about, trying to learn new segments where I'm not exploring. So sometimes reducing complexity could give you not a cathedral, but a very tiny church, and you're not going to build a cathedral on top of that church. So what do you think about this?
I mean, if you understand the business, I think you can avoid this, right? If you really know what you're trying to build. I mean, the whole point is you have to build a real tiny cathedral, right? Not a tiny house, but really something which resembles the final product. I think for that, you really might focus on understanding the business, understanding what domain you find yourself in. I think that's very important. You have to evangelize your data people. They have all of them to understand a bit of product development, in my opinion. I think like this, you can avoid, I think. This type of issues.
Okay, evangelization, churches. I like the idea. Okay. So now let's go to the questions that we have here. So the first one by Nemanja. Sorry, probably not well pronounced. Is it good? Okay. Why agile goes wrong so often?
Why data goes wrong? So
Agile.
Oh, wow, that's my favorite question. Yeah, agile is like a curse word in our field, right? I mean, no data leader would say agile is great. I've never heard this. I do think people are too dogmatic. This goes to the cargo code, right? When you do agile, a soft version works, yeah? I mean, there's agile and agile. There's the agile where you have an agile coach, which asks you to estimate your story points for your machine learning work. Yeah, I've seen that. It's not great. It doesn't feel great. So if you avoid like these dogmatic parts of agile, actually it can work. I think for us, instead of doing whatever sprints with story points, you can just work in Kanban. Maybe it helps, but I do think some kind of it's like Jira or PowerPoint, this type of things which all of us love to hate, but without them, we're kind of, there's nothing we can do, right? So I think kind of softening this up to have like more gray approach to this works, to be honest, yeah.
Okay, thank you. Okay, another one. I think we have time for a couple of more. How do you suggest to manage expectations from product end users when closing the loop with imperfect MVPs?
That's a very hard question. How do you manage the expectations? I mean, managing expectations, the most important part there is you do it on time. It's not great to manage expectations when you're presenting your product to the C-level people, right? I mean, you can try to manage those when you have that situation, but it's too late. So I think if you are early enough in the process, you explain to them what you're doing, you tell them this is not a great model, but we deploy this, then it's much easier. And to be honest, it's better to under-promise than over-deliver. So keep that in mind, I think, as well.
Okay, cool. Just the last one from Felipe Justiça. Where do you feel like there's more waste on an AI project?
Most waste. I think the waiting waste is really not great. I think we have but the most painful waste, which is kind of insidious, this is what I mentioned in my story from that food delivery company, is this requirements. Yeah, nobody defined what we need to build, and that's, I think, the worst source of waste, because you feel that everything is developing fine. You develop your product, but then you realize nobody cares. Yeah. So I think that's the worst waste.
At the beginning.
Yeah, exactly. Somebody needs to define what are we trying to do, actually, specifically.
Okay.